30% ice. Martian glaciers are cleaner than previously thought. What are you waiting for? Martian glaciers are cleaner than you think. Imagine setting foot on Mars, only to discover that the red planet's glaciers are more than just dusty, rocky landscapes. In fact, they're predominantly composed of pure water ice, a game-changer for future explorers seeking resources for life, air, and even rocket fuel. But here's where it gets fascinating. Scientists once believed these glaciers were only 30% ice. How wrong they were. The ice revelation. Decades of research have gradually chipped away at the initial assumption, suggesting some Martian glaciers might be cleaner than thought. Now, an international team of researchers has confirmed this hunch, revealing that glaciers across the planet are comprised of over 80% water ice. This groundbreaking discovery was made possible by the radar instrument SHARAD on board the Mars Reconnaissance Orbiter, MRO spacecraft, uncovering the ice-rock ratio. By analyzing how quickly radar waves pass through and scatter within glaciers at 5 carefully selected Martian sites, the team uncovered a surprising uniformity in the glacier's purity. It turns out that despite being covered with a layer of dust and soil, these glaciers boast a remarkably consistent ice composition, regardless of their location on the planet. What does this mean for Mars' past and our future? A uniform composition of Martian glaciers hints at consistent environmental conditions across the planet when the ice formed. This could be attributed to atmospheric precipitation, snowfall, or direct condensation due to frost. Interestingly, it seems unlikely that the ice formed through the diffusion of water vapor into subsurface layers, a process observed in regions like Alaska and Antarctica on Earth. The bigger picture, implications for manned missions. This finding is a crucial piece of the puzzle for understanding Mars' history and planning future manned missions. Accessible ice deposits could become a vital resource for success, as highlighted by this discovery. And, as we previously explored, the possibility of brines existing on Mars' surface adds another layer of intrigue to the planet's potential for supporting life. Now it's your turn. Do you think the discovery of predominantly ice-based glaciers on Mars significantly boosts the chances of successful manned missions? Should space agencies prioritize the exploitation of these resources for future settlements? Share your thoughts and opinions in the comments below. Sources: Universe Space Tech's previous report on potential Martian brines, https universemagazine.com/brines may exist on Mars. Space.com's coverage of the Martian Glaciers study, https www.space.com/astronomy/Mars/good news for Mars/red planet glaciers are mostly pure water ice, study suggests. About the author. Part of the Universe Space Tech team since 2017, our author specializes in interplanetary missions, space exploration history, rocket launches, and scientific discoveries in near and deep space. With a lifelong fascination with space, he brings accuracy, structure, and a deep respect for scientific knowledge to his engaging writings. Water on Mars, a game-changer for future colonization. Water on Mars, a game-changer for future colonists. Imagine a future where humanity thrives on the red planet, with water no longer being a scarce resource but an abundant blessing. This isn't science fiction anymore. New research suggests that Mars might hold more water than we ever imagined, making colonization far more feasible than skeptics once thought. And this is just one piece of the puzzle in this week's exploration of groundbreaking discoveries and innovations. For years, scientists have known that Mars has glaciers scattered across its surface, but these icy formations were largely assumed to be a mix of rock and ice, not exactly the ideal source of drinking water or fuel for settlers. However, recent findings published in Science Direct, https www.sciencedirect.com/science, article pi S0011910352647, reveal something astonishing. Martian glaciers are composed of over 80% pure ice in many regions. This revelation came after researchers reevaluated previous data using radar instruments aboard NASA's Mars Reconnaissance Orbiter, which has been orbiting the planet since 2006. By standardizing their methodologies, they uncovered that these glaciers are essentially massive reservoirs of water hidden beneath layers of rock and dust. Even more intriguing, glaciers located in vastly different parts of Mars share nearly identical ratios of ice to debris, simplifying the process of extracting water for future colonists. But here's where it gets controversial. Does this discovery truly make living on Mars inevitable? Or does it merely shift our focus to other challenges, like radiation exposure and sustainable agriculture? As you ponder these questions, consider how transformative this could be for humanity's next giant leap into space. Do you think we're ready to become an interplanetary species? Now let's dive into another exciting frontier: how artificial intelligence, AI, and lab-grown mini-organs could revolutionize drug testing and potentially bring an end to animal experimentation. Picture tiny, beating hearts, visible only under a microscope. These organoids, grown from human stem cells, aren't just fascinating. They're already helping doctors tailor treatments to individual patients at places like Children's Mercy Hospital in Kansas City. For example, instead of relying on trial-and-error methods to find effective medications, physicians can now test drugs directly on organoids derived from a patient's own cells. This technology also holds promise for replacing traditional animal testing, which has been mandated by law since the tragic elixir sulfanilamide incident of 1937. Despite rigorous animal trials, some approved drugs still cause harm when administered to humans. To address this issue, scientists are developing alternatives like organs on a chip, miniature devices embedded with clusters of human cells that mimic real organs' functions. In a groundbreaking study highlighted in Nature, https://www.nature.com/articles/S43856-022-0209, researchers demonstrated that liver chips accurately predicted toxic effects of certain compounds, proving their potential as a faster, cheaper, and more ethical solution. With billions of dollars wasted annually on failed drug candidates, adopting such technologies could significantly reduce costs while improving safety. And this is the part most people miss. Beyond the obvious moral arguments against animal testing, there's a strong economic incentive too. Pharmaceutical companies currently spend upwards of $2 billion to develop a single drug, yet over 90% fail during clinical trials. Could AI-driven tools and organ chips finally break this cycle of inefficiency? Share your thoughts below. Moving on to medical breakthroughs. mRNA vaccines, the same technology behind the COVID-19 shots, are showing potential in combating HIV. While a cure remains elusive, a recent clinical trial involving 108 healthy participants revealed encouraging results. The vaccine triggered antibody production without severe side effects. Though further research is needed, experts believe this approach could pave the way for a long-awaited HIV prevention strategy. Finally, let's gaze beyond our solar system to a star system called L98-59, located just 35 light-years away. Astronomers have confirmed the existence of a fifth potentially habitable planet in this system, all of which resemble Earth in size and mass. What makes this particularly thrilling is that each planet resides within the habitable zone, where conditions may allow liquid water to exist. Imagine the possibilities if the James Webb Space Telescope uncovers signs of life there. So, what do you think about these advancements? Are we on the brink of solving humanity's greatest challenges, or are there hurdles we haven't even considered yet? Join the conversation and let us know your take. Breaking: Mars glaciers are 80% pure water ice. Game changer for Mars settlers. Exciting news for those dreaming of settling on Mars. A recent study reveals that the glaciers on the red planet are predominantly composed of pure water ice, indicating they could serve as valuable resources for future explorers. For many years, scientists have observed glaciers on Mars that are often covered in dust, particularly on the slopes of its mountains. Earlier research had proposed that these glaciers were either primarily rocky, containing as little as 30% ice, or debris-laden glaciers that were over 80% ice. Isaac Smith, a senior scientist at the Planetary Science Institute in Tucson, Arizona, and an associate professor at York University in Toronto, noted, various techniques have been employed by researchers at different locations, making it challenging to compare results effectively. To clarify the makeup of these Martian glaciers, the research team utilized the Shallow Radar, SHARAD instrument aboard NASA's Mars Reconnaissance Orbiter. They examined 5 distinct sites on Mars, focusing on the speed at which radar waves traveled through materials and how quickly energy dissipated, which provided insights into the rock-to-ice ratio within the glaciers. We were surprised to find a remarkable consistency in the purity of these glaciers, stated Oded Aharonson, a professor of planetary science at the Weizmann Institute of Science in Rehovot, Israel, and a senior scientist at the Planetary Science Institute. All the locations we studied can be characterized as relatively pure ice deposits, with perhaps 80% or more ice beneath a layer of rock or dust. This could be a significant resource for humanity in the future if we attempt to access them. Interestingly, the composition of these glaciers was found to be similar even in the planet's opposite hemispheres. This suggests that the environmental conditions under which the ice formed and was preserved were likely uniform across Mars. Aharonson elaborated, the ice might have formed through atmospheric precipitation, such as snowfall that contributed to glacial development. Alternatively, it could have formed through direct condensation, where frost develops directly on the ground. However, it seems unlikely that it formed through pore ice formation, which occurs when water vapor from the atmosphere diffuses into the subsurface and creates ground ice. This process is known to happen on Mars and in places like Alaska and Antarctica. If the ice in these glaciers had formed in that manner, we would expect to see much higher levels of impurities, which is not the case here. The research team plans to investigate additional glaciers on Mars to further solidify their understanding of the ice present across the red planet. Their findings were published online on July 12 in the journal Icarus. Join our space forums to continue the conversation about the latest missions, night sky events, and more. If you have any news tips, corrections, or comments, feel free to reach out at community@space.com. Charles Q. Choi, a contributing writer for Space.com and Live Science, covers a wide range of topics, including human origins, astronomy, physics, and general science. He holds a Master of Arts degree from the University of Missouri, Columbia, and a Bachelor of Arts degree from the University of South Florida. Charles has traveled to every continent, experiencing unique cultures and adventures, from drinking yak butter tea in Lhasa to snorkeling with sea lions in the Galapagos, and climbing an iceberg in Antarctica. Visit him at http://www.scywriter.us.